Hello everyone. In this session, we are going to learn some of the very basic algorithms present in C++ language. The basic one is min. We're going to find how to use min to find out the smallest of two elements. Then we're also going to learn about the max, which is going to find out the largest of two elements. Then we're also going to learn how do we find out the largest element in an array of elements, and then the same way the smallest element in an array of elements. So let's begin using the minimum function. Now before we use this min function, let us take up two numbers. Let's just take up two numbers. I want to find out the smallest of two numbers. Now if you want to find out the smallest of two numbers, you can use the function name, which is min. It takes two variables, a and b. It returns the smallest element, and then we can just try to print the result. This is going to print the smallest of two elements. Now let's quickly try to learn how do we use this. Perfect. The smallest is 4, or you can just change this, then recompile it here. Fine. Perfect. Now since again this has been implemented with the help of templates, we can use it with various data types. Let's try to learn how do we work with strings. Right. So you would like to directly print it here. Perfect. Now here the smallest one is selected based on the alphabetical order, not based on the length, right? In this example, Nihad is smaller because it has n comes before s, right? Let's quickly try to compile this. Perfectly fine, no issues. Now if you want to work with max, just replace this min with max here. And the same way here. Max again takes two arguments. Perfectly fine. Oh yeah, if you want, you can change this input. You want to find out the largest, so I'd like to take up. Fine. See, if you consider the alphabetical order, P is lesser when compared to S, but if you consider the length, P is greater, okay, the Purushottam is greater when compared to Sikander. Let's quickly verify, is it doing based on, remember we're also working with max, not with min. Maximum Sikander, right? Because S comes after P. Perfect. Yes, even if we have to write this code, it is too simple, right? Now you can make use of this particular function to also work with user-defined data types. We'll just see this once we find out how do we find out the smallest element and largest element in an array. Then we'll come back to using the max and min with user-defined data types. Now if you have two elements, perfectly fine, but if you have an array of elements, or might be a vector of elements, right? Now let me just take up an array of elements. You have some elements here. Some elements. Perfect. Now I want to find out the smallest element, and I would like to find out the largest element. The function to find out the smallest element and largest element is, we have a function called as min underscore element. There's an underscore there, right? Wherein we pass two arguments. We basically pass the starting address of an array and the end address of an array. 1 2 3 4 5 6 7 8 9. Right? Perfect. Fine. But this function does not return the smallest element. Instead, it returns the address where the smallest element is present. Now we can just say it's pointed to small. Same way, if you want to find out the largest element, we have a function called as max underscore element. right? Perfect. Fine. Now if you have the pointer to the smallest element and pointer to the largest element, and if you want to know what is the element, just dereference the pointer. Let me just quickly write down here. Pointer to small. The same way I'd like to also take up the largest element. Fine. For the time being, let me try to disable this code. I'll come back to this. Perfect. So let's quickly compile this code. Fine, the smallest is 2 and the largest is 45. Now if you want to find out the index where the smallest element is and where the largest element is, we can just perform this by just performing a pointer subtraction. We have the address of the element where the smallest element is present. We have the base address. Just do a pointer subtraction, you will get the index. Here. So you have the pointer where the smallest element is minus the base address. Perfect. The same way we can just see perfect. Now let me save this again. You can see the largest element is the third element, which is at index 2, and this is my seventh element, which is at index 6. So let's quickly run this. Perfect. So we just learned how do we find out the largest element and the smallest element, and also get to know the index where the smallest element and the largest element is present. Quite a simple one, right? Yes, it can also be worked with strings. You can just replace this to a string. It works perfectly fine. Now let's try to take up with string, but let us not take up a traditional array. Let us try to take up a vector of string, right? Now let's add some elements to this with the help of initializer list. Remember, the initializer list is only present in C++11, so you can just add on these names. Let me just take up these names. And let us try to add up some more names. Perfect. We have added some names. Now, since you're working with vectors, if you want to find out the largest and smallest, the function name remains the same, but you just cannot pass v comma v plus number of elements. We can just use begin of v, which we could also use it with a basic arrays, and then end of v. But remember, this feature is a C++11 feature wherein you can initialize the elements of a vector in the same line where you're declaring it, as well as using this begin and end function is also a C++11 feature. Now what does it return? It does not return a basic pointer, it basically returns an iterator. It returns an iterator. Now you can declare an iterator in this way, since a vector to string. Perfect. Now using this iterator, let me just try to print this. So I'll just write largest string or smallest string. Perfect. And at index, right, you can just write it minus v dot begin or begin of v. Perfectly, anything is fine. Fine. Yes. Yeah, since we are working with vectors as well as we are working with strings, we need to include the header files vector and a string. Fine. Let me save this once more. Oh, can you just observe? We cannot use begin, we cannot use initial list with C++98, so we need to use std equal to C++11. Perfect. Now let's try to run. So we can just see the smallest element out here based alphabetical order is Bhargav, which is the fourth element at index 3. Perfect. Now you can also do the same thing with max. I'm just changing the function name, not changing the corresponding strings and all here. The largest element here is starting with V, Vaishak. Fine. Remember, I have not changed this string here. You can just change the string if you want. Perfect. So we learned how do we find out the smallest element in an array as well as the largest element in an array, which basically returns the location or the index where the it does not return the index, it basically returns the address where the smallest element and largest element is present. We can just dereference the pointer to get the element, and then we can also use the same pointer minus the base address to fetch the index. Right? When you're working with primitive arrays, we just work with the primitive pointers, but if you're working with vectors, then we work with iterators. Yes. Okay, if you find this particular declaration a bit complicated, you can always use auto here, because C++11 does support auto, wherein the data type of this iterator object is determined automatically based on whatever you assign. Perfect. So if you just want to find out, cross verify this, you can just quickly cross verify this. Perfect. I hope there's no problem. Right. Now we work with min and max and min underscore element and max underscore element with built-in integers and built-in strings. Now in case if you're not working with primitive arrays or strings, we're working with user defined data type. Let's consider that you have a list of records, student records, wherein you have registration numbers, the names and the marks of the student, and then you want to find out who has scored the smallest or who has scored the highest. Okay, so if you want to do that, how do we do this? Let's quickly try to look into that. Now I'd like to create a class student. Let's quickly consider the members here. Perfect. 3 things are sufficient. Now I'd like to add a constructor here. Then we have P, just so that I don't want to make the parameter name hide the data members. That's the reason why I'm just using P for the parameters. You can use the initializer list, or I can just do it in the body part of the constructor. I hope there is nothing to be explained about this. A simple constructor which takes the parameters and then assigns it to the data members. Yes, we do not have a default constructor if the user provides the parameterized constructor. That is something what we need to be aware of. If the user provides a parameter constructor, the compiler does not provide a default constructor. Then Let us also have a simple code, like if you want to overload the insertion operator, then we're just going to overload this insertion operator. Friend has to be present only inside the class, not outside the class. It's a global function which we want to access the private members of the class. Can use cout or O. O is a reference for cout kind of thing. We can write the registration number. Probably we can just have a space in between, and then we'll try to print name. And then we'll try to write the marks. Perfect. Now this is quite a simple code, wherein I just created a student class and then a constructor and an insertion operator. Before we start using it with max, min, or max underscore element and min underscore element, let's quickly verify, did I create this perfectly or not, the class. Then we'll see that in case if you want to work with max and min, is this sufficient or do we need to add something more? So let me just try to create a student object, student s1, right, equal to, we can just use a uniform initializer. This, if you want to use this notation, is again a C++11 notation, or you can just use a regular notation, wherein let me just say my name is this and I've just scored this much and like to write s1. Perfect. Let us just quickly to verify that did I write it correctly or not. If with no expression, so if of 0, right. Remember, we have not used any C++11 feature. Even without C++11 it works. Perfect. So once we have tested that this works perfectly fine, then let us try to find, take two students objects, try to see whatever we have written, is this sufficient or do we need to add something more. Fine, perfect. So I'd like to print this. I'd like to find out the smallest, who has scored the least between S1 and S2. Right, perfect. Now let's try to compile and see, will it work or not. And you can observe that it's giving me an error, and it's basically saying that we do not have a less than operator. With respect to integers or strings, the less than operator was already provided, but in case if you're working with user defined data types, then we do not have the less than operator. So if you want to make this minimum function work with user defined data types, now it's our responsibility to add the less than operator. We need to overload the less than operator. So we can just overload the less than operator. Since it's a relational operation, we can just have return type as bool, right? And then if you're adding another member function, then you will have only one parameter, const. And then since it does not modify any of the data members, we can also make it as constant member function, plus the parameter can also be a const. You want to compare based on marks as then we can just write marks less than s dot marks. That's it. It's a relational operation. It is a boolean value. Perfect. Nothing more. We just added this code, which is basically overloading the less than operator as a member function. It can also be done with the help of global function. Let's try to quickly compile this. Perfect. The smallest among them based on the marks is Sikander. We can just change the marks. We can just change that to Let us say this is something like 86. Then we'll try to recompile it. Now the smallest among them is Purushottam. Perfect. Now, if you want to work with max, what do we think? Should we overload the greater than operator? Let's quickly verify. There is no need to overload the greater than operator. It works perfectly fine because max function also uses a less than operator and the min function also uses less than operator. So you can just assume that like inside the body part, it's like as if like you're writing A is less than B, return A, otherwise B, something like this. Then in the other function, the max, we'll just write B, otherwise A. In both the cases, this what you're going to use is basically the less than operator. Fine. Okay. So less than operator is something which we need to overload if you want to work with smallest or largest of two elements. Now in case if you want to work with an array of elements, the max underscore element and the min underscore element, and those two functions also internally use the less than operator, we need to overload the less than operator if you want to find out the smallest or largest element with any other use a different data type. Since we already overloaded that, only thing what you need to do is instead of creating one simple two objects, let's try to create a vector of students, vector of student, right? So let me just try to use pushback, or you can use right, or you can also use the brace initializer list, which is perfect. I can add few more records. You can place the names of whatever you want it. Perfect. Now we already learned how do we use max and min. I just want to use max underscore element and min underscore element. So I'm just going to use max underscore element. I'm going to pass begin and end. We can write s dot begin comma s dot end. Perfect. It returns me an iterator which I can just dereference it. Perfect. The largest element based on the marks is the fourth record and the smallest element is the third record. You can modify the data here if you want. Perfect. So you want to work with min. Just change this here. Perfect. You can change the marks. Yeah, if you want to find out the largest or smallest based on not on the marks, in case if you want to do it based on the names, just do the changes here. Instead of marks, just say that I'm going to use name less than s dot name, which is string, so it is perfectly valid. So here, since we're using the smallest out here is again back to a. These are here. Then if you want to find out the largest is yes among the four, it is Sikander. Sorry, it is Veena, because V is greater when compared to other P and S and A. Perfect, right? Yeah, if you want you can change that. Let us say we'll just change it to Reena, then fine. Okay, so key points to understand here is the max underscore element and the min underscore element does not return the smallest or largest element. They return an iterator. If you're working with vectors and all, it's like iterator to the smallest element and the largest element. Okay, and then in order to find the index, we can always use the pointer subtraction, or you can say the iterator minus the begin address. We can always get the index. Perfect. right? Even here we can just apply that. Okay, whatever the iterator what you get, okay, then you can just apply that. Fine. Yes, in this I have used s dot begin and s dot end. If you want, you can use begin of s and begin of uh, end of s, which is a C++11 feature, right? And then again, since I was only printing the elements, I do not capture the return value of max underscore element into a separate variable and then using it. You can, if you want, you can capture it. And then to simplify it, you can always use auto there rather than explicitly mentioning the lengthier declaration of the iterator, right? So anytime further, if you want to find out the largest element or the smallest element, either it might be largest of 2 or smallest of 2, or might be, okay, or a group of elements, either it might be a primitive array or a vector, you can always use the built-in algorithms rather than rewriting your own code. Thank you.